Good afternoon, morning, evening, whenever you're watching Scholars, and welcome back to our mini unit on transformations. We're going to continue to chip away at this idea of horizontal and vertical adjustments to our graphical representation of functions. So today we're going to learn to create an equation to represent the vertical and horizontal translations needed to move one graph to another. So I can describe the effect on a graph by replacing the function with f of x plus k, or f of the quantity x plus k. I'll know I've got it when I understand the relationship between graphs, equations, and describing horizontal translations. Let's get into it. So in this image here, we have function a, which is our solid black line. And I would like for you to describe how we can translate the graph of a to match one of the other graphs. You should be able to identify that there is one graph we are unable to translate the graph of A to. We could relocate A to match it quite closely, but not to a specific degree. In our next slide, we're back in the kitchen with my boy Gordon Ramsay. We have our bakery with the thermostat set to 65 degrees, and at 5 a.m., the kitchen rises to 85 degrees, so on and so forth. Andre thinks when the bakery starts baking 2 hours earlier, this means that I need to subtract 2 from x, and that g of x is equal to h of x minus 2. How could you help Andre understand the error in his thinking? We spoke about this in great length in our last lesson, but remember that just because we are shifting the graph of g to the left based on the original orientation of h does not mean that we are actually decreasing the input value, because the input value is contingent upon the location of the original function, in this case h. So when we take a look at g of 6, let me bust out my pen, my writing utensils. G of 6 seems to be the middle point. If we look at the corresponding point on the graph of h, we can see that is at an input value of 8. So in order to algebraically represent what has happened, what mathematical operation and by what quantity do we need to modify the input value of g in order to return g to its original location in h? So this graph of f shows the temperatures after a change to the thermostat settings. Describe in context what the owner did. So take a look at the output. It appears that the graph has been raised and appears to be that's awkward, but I guess a natural part of our videos. So once again, it appears that the bakery owner has increased the temperature, but I will leave that to your own interpretation, and then create an expression for f in terms of the original baking schedule. So that would be this left-hand graph. Okay, what is happening between the two? Graphically here, we have the graph here represents a piece of meat that is taking out of the freezer to thaw. The data points show its temperature M in degrees Fahrenheit, T hours after it was taken out. So the temperature initially was 13.1 degrees, and then obviously over time, we can see that the temperature was increasing. Someone decided to create a function to model the data, but it clearly does not align. Jada thinks that if she modifies her expression in this fashion, that would be a better model for the data, whereas Noah thinks that making this adjustment would be a better idea. Before we even get to see what those functions look like, I would like for you to describe the adjustments that Jada and Noah did and how it's going to affect the graph of the original function. Here we can see that the blue line represents Jada's adjustment and Noah is represented in green. Whose function do you think best fits the data? And be prepared to explain your reasoning, so make sure you share that with your classmates. Okay. Attend to precision here using the vocabulary that we've been working through. And with that being said, that's all we'll be doing here since we've been having this circuitous conversation regarding the function notation and the graphical representation of translations both horizontally and vertically. So we'll pick up together in class.